Hello everyone, in this video we are just going to see and walk through the user manual and datasheet of TM4C123GH6PM microcontroller. Let's get started. So in the previous video, we just walked through the STM32F446RE microcontroller datasheet and user manual, and then we derived the GPIOA peripheral base address and all the other GPIOA register addresses as a whole. And in this video, we are just going to do the same thing, and we are going to fetch the GPIOA base address in this microcontroller TM4C123, and then we are just going to walk through the block diagram of this microcontroller TM4C123GH6PM. So these are registers and base addresses of the microcontroller STM32F446RE, and now we are just going to derive the same for TM4C 123 GH6 PM. Let us see the datasheet block diagram for better understanding. So here we can see the block diagram on the screen. This microcontroller is having two different bus matrix as we have seen in the previous microcontroller. One is the AHP bus, that is the advanced high performance bus, and another one is the advanced peripheral bus, that is APB. And these are all the peripherals. That is on the left is the peripheral that is connected to AHB and it is driven from AHB, and these are all the peripherals on the right, that is watchdog timer, UART 8 UART ports, 4 I2Cs, 2 CAN drivers are connected to APB peripheral and which are driven through that APB bus, and that's it. Now let us go to the memory map table for understanding the memory map of this microcontroller. So click on the list of tables and you can see here is the memory map in the page number 92. So this is the memory map of this microcontroller, and on chip flash starts at this address, which is the program memory, and SRAM, that is static RAM, starts at this and ends at this. On chip flash starts at this address, that is 00000000 and ends at this address. And here comes the peripherals, that is the streets that we have seen in the previous microcontroller, and we are just going to choose the GPIO port A, right? So we are just going to derive the addresses of each and every register of this GPIO port A in this video. So let me just find the base address of this peripheral, that is this one. You can see 0x4000 is the base address of GPIO port A. This is the base address of GPIO port B, port C, port D, etc. So let me just take this address. This is the base address of GPIO A in this microcontroller. You can clearly see this is the base address of GPIO A in STM32F446RE microcontroller, and this one is the base address. So based on the silicon vendor, these peripheral addresses may vary, although the ARM Cortex M processor is same in these two microcontrollers. And let me just open the GPIO peripheral for register descriptions. General purpose input output, just click on the register map. So this is the register map of this GPIO peripheral in this microcontroller, and we are having this much registers. You can clearly see nearly we are having many registers related to GPIO peripheral starting from this data register. So first and foremost register is GPIO data register and its offset is 0x000. So GPIO data register and its offset is 0x000. Next register is GPIO direction register and its offset is 0x400. So this will provide me the same value since the offset is 0. So now the offset of this DIR is 400, so I will get 4400. Third register is GPIO IS interrupt sense register, which will be having offset of 0x04. So address of this register will be 0x4000 4404. Next register will be GPIO IBE interrupt both edges, which will be having an offset of 0x408. So the address of this will be 40004408. Next register is GPIO IEV interrupt event register, which will be having the offset of 0x40C from base. Next register is GPIO IM interrupt mask, which is having the offset of 0x410. Next register is GPIO raw interrupt status register and it is having the offset of 414. Next register is GPIO MIS register masked interrupt status register, which is having the offset of 418. Next register is GPIO ICR interrupt clear register, which is having the offset of 420 41C. And the next register is AFSL analog select and it is having the offset of 420. And similar to this, you can use this base address of GPIO-A and along with it. So similar to this method, you can calculate the register address of any register under this GPIO-A using the base address available right over here plus the offset address of that particular register. If you add the base address of GPIO-A with that particular offset of that register, you will get the register address. So base address plus offset of this GPIO MIS register will provide you the address of GPIO MIS register. base address plus offset of GPIO data register will provide you the GPIO data register address, and so on. So using this methodology, you can find the register address of any peripheral by adding the offset of that register with the base address of that peripheral in this microcontroller TM4C123GH6PM. So I hope you learnt block diagram of this microcontroller TM4C123GH6PM, and also you understood how to find any register address of any peripheral in this microcontroller TM4C123GH6PM using the memory map table of this microcontroller along with the offset address of that register available in the datasheet or user manual of the microcontroller. See you in the next video. Thanks for watching.